Hello, this is Team 8. Our project is named Clutching at Straws, studying regenerative design on bio-based materials. This diagram shows the comparison between different building materials about how much carbon dioxide they produce cradle to gate per kilogram. We can see that bio-based materials, for example straw, wood fiber, timber, and hempcrete, have totally different characteristics to conventional materials such as concrete, steel, and plastics. They not only have lower carbon emissions in the process, and even absorb the carbon within themselves. This means that using bio-based material in construction may have significant improvement compared to the current building methods. So here is a representative project called the Lilac, located in Leeds, built with prefabricated straw panels produced in Bristol. It costs less money to build and has extraordinary insulation performance due to the characteristics of the materials. But still, transporting the prefabricated straw panels from Bristol demands several trucks driving hundreds of kilometers. Our calculation shows 7.48 kilograms of carbon dioxide emissions were produced in each round trip per truck.
Straw in the Wind is the winning competition proposal for the Eco Home Pavilion in the City of London promoted by the London Festival of Architecture. With the straw filled into the timber frame structure, Mortcell Company provides this kind of prefabricated straw panel that can be directly used as a load-bearing walls or non-bearing walls. Straw in the Wind uses these panels to structure the pavilion, and through revolving the panels, it can open or close the walls, allowing people to pass through every side of the pavilion and making it a versatile space for a flexible future program. Despite all these relevant and important aspects of promoting bio-based materials, the pavilion does not discuss where the materials are coming from and how they are being produced. So we would like to ask, what does it take to produce these materials, and is it possible to produce them on site? To answer these questions, we started by analyzing the pavilion structure to understand the components that they are using. In order to have a further understanding of how the system works, we calculated the amount of material needed for this pavilion. This is the canopy, which consists of timber and recycled plastic sheets. Timber is about 1,344 kilograms and plastic is around 54 square meters. As for the housetop, the beams are all made from timber. Approximately 1,152 kilograms of timber is used in this part of the structure. Beneath the top, 4 timber posts support the ceiling, and all the surrounding walls are made of straw panels. In the panels, there are at least 1,280 kilograms of straws, and the timber frames weighs about 384 kilograms.
And this is another project we can learn from, called the Wakelings Farm. Wakelings Farm is a 22.5-hectare arable farm in Suffolk. They have experimented with agroforestry systems and collaborated with the Organic Research Center to collect data and promote sustainable agriculture. Their alley cropping way has been proven to be the best way of crop farming nowadays. They have in total 56 rows of trees in the whole area. The tree rows gap from 10 to 12 meters, with crops farmed in between. They can prevent insects from attacking crops from land to land and keep fragile crops away from the strong wind. They also help to build up the environment in the area. This diagram shows the biodiversity evolution in the first few years Wakelings Farm was established. Using Wakelings as an inspiration to organize agroecological farming, we are going to select a piece of land where we can potentially plant and harvest straw to build the Straw in the Wind pavilion, but also to introduce agroecology so the pavilion can be provided with materials and products by an agroecological landscape. We select this piece of land within the Queen Elizabeth Olympic Park. It's in the east of central London, used for the 2012 London Olympics, and is now a part of the parklands. The land marked in red is today a rarely used lawn within the park, with little or no vegetarian, with an interesting location next to Here East, a hub of creative and vibration industry from where we could draw some synergies in the future. Our plan is divided into 3 major parts: healing, farming, and sharing. When we looked into the site, we noticed that the soil health was influenced by former construction behavior that happened upon it. The first thing to do is to heal the soil. After restoring the nutrition of the soil, we should move on to farming. Farming includes crops and other vegetation, and after harvesting enough, it is to share the benefits of the harvest.
This drawing shows the initial process on our land. It is the nitrogen fixation process. These nitrogen fixation plants can fix atmospheric nitrogen and store it in root nodules for their own use and benefit plant neighbors by ramping up activity levels in the rhizosphere. In the following days, shade trees absorb nutrients produced by nitrogen fixation plants. Fallen leaves increase the thickness of the soil humus layer and provide nutrients for nitrogen fixation plants. Transpiration and shading reduce the ambient temperature. With the healing, the soil within the land would be fertilized, and more small plants could be planted. The trees, shrubs, and flowers together build up the environment and promote the biodiversity greatly compared to the heath at the beginning. In the second year, trees are growing higher, and crops can be farmed. We choose wheat because, as the most suitable crops for the climate here, it is the largest farmed crop in England. The wheat will be farmed between the tree rows, and each farming area is about 10 meters wide. Some cottages will be built to meet the needs for the following days. In the third year, the wheat will be harvested and stored on the site. From the wheat's dry matter, the straw will be collected and then made into prefabricated panels. Then the panels can be used to build up a pavilion. The straw collected from our land can sum up to 1.6 tons, enough to build a pavilion exactly like the straw in the wind. Having all these processes locally means we can save a lot of carbon emissions from transportation. And in the fourth year, crop rotation will take place and land will be efficiently used to farm vegetables, fruits, and crops. The whole site will become a community farm and a garden open to local citizens.
For our project, we will focus on straw and what is needed for its production. The first picture illustrates what a wheat crop looks like. After harvesting and drying, we acquire the dry matter of the wheat, in which 51% of the weight belongs to the grain, 32% belongs to straw, 11% belongs to chaff, and the rest 6% are leaves and dead shoots. According to existing statistics, in 1 hectare of land, you can harvest 18.4 tons of dry matter in 1 year, and 32% of them are what we know as straws. To be on the safe side, you can count on 25% to make up the loss through the transportation and selection. So that means we can acquire 4.6 tons of straw from 1 hectare of farming land.
Current situation: there is sandy soil on the surface, currently overcovered with grass, and some earthworms about 10 centimeters after digging down. First year, using 3 kinds of nitrogen-fixing plants to transform the soil of the site. There are nitrogen-fixing bacteria in biosis on the root system, and the soil's nitrogen content can be increased after planting. Second year, winter wheat is planted in some areas in the fall, with small trees and shrubs planted in between. Third and fourth years, winter wheat is harvested in summer, and the straws are used to build the pavilion. The remaining site is divided into 3 parts, so that annual vegetables and fruits can be planted on 1 part every year, and the rest of the site is rested to replenish fertility.